Hello everyone, welcome to my talk today on GitHub-OSS Fixit, Fixing Bug SQ in a Software Engineering course. My name is Xinghui Tan. This is a joint work with Chunfeng Hu, Zhiqiang Li, Xiaowen Zhang, and Ying Zhou. All of us are from Southern University of Science and Technology in Shenzhen, China. Before I begin to talk about our projects, I want to introduce several approaches that use open source softwares to encourage more people to contribute to open source. One of the most popular programs is the Google Summer of Codes. However, it's limited to the organizations that have signed up for Google Summer of Codes. It's also limited to the listed projects that have implementing features. And what is more important is that it has a long registration process where students and mentors need to sign up for these programs. There's another similar programs called FindBugs Fixit, where a group of Google engineers actually participates in this Fixit. But they are only fixing issues related to FindBugs. FindBugs is a static analysis tool. Compared to all these approaches, our approach called GitHub-OSS Fixit is actually more flexible because it allows students to select any projects and any issue that they are interested in fixing. The key idea behind GitHub-OSS Fixit is that we're trying to emulate the role of mentors by using developers of open source projects who have open GitHub issues. So the key idea here is that students can fix bugs in these open source projects because for each GitHub issues that's actually define a bugs, they have an implicit mentor roles. This is the overall timeline for the GitHub-OSS Fixit projects. You can see that it spans several weeks, including it started the class or around middle of February. This actually was conducted in the middle of COVID-19, where students actually couldn't come to actually have the offline teachings. So the entire course project is conducted online. There are three main stages for the GitHub-OSS Fixit, including the project proposal stage, the progress report stage, and the final presentation stage. After the final presentation, students are given 1 week to vote for their best groups, where the best group need to submit the video to describe why they deserve to win the best prize. Next, I want to describe on the most important elements of the GitHub-OSS Fixit, that is how to select projects and issues. For the issue selections, we ask them to select issues that are important. We want them to look at issues with tags like up for grabs, help wanted. They can also find the issues that are suitable for beginners by looking at the contribute links. And we want them to make sure that one issue should not have any fixing commits because they should not be competing with the developers or other users to fix a bug. And another important thing is that we want them to make sure that an issue is reproducible. So because they need to have a test case to reproduce these issues in order to use the same test case to validate whether they have fixed the bug correctly. And to prevent them to select a lot of trivial issues to fix, we ask them to make sure that the lines of code should be greater than modifying or adding 10 lines of code. And then the estimated time to resolve an issue should be at least 1 to 2 weeks instead of 1 to 2 days. After they have selected the issues, they need to actually fill out this table that you see here. That is, they need to mention what is the number of people that is required for fixing these issues. We allowed up to 2 members for each issue because we want to encourage pair programming, which is one of the important practice in extreme programming, XP. That is one of the software development methodology that students use for developing these projects. We also ask them to have the estimated time to fix an issue, estimated difficulties to fix a bug. To actually ensure that they have actually produced good quality codes, we assign different roles to different members. that is, apart from the leader role, we also ask them to have one person as the designer who are in charge of the contribution guidelines and the code review. And then there is one student who play the role of tester who are in charge of the quality of the test case that are being written. And then the other person should be in charge of the documentations of the code. Next, I want to share with you the lesson plan that have won the World Teachers Day Challenge. This World Teachers Day Challenge is co-organized by TweetLoQuest and GitHub. In the lesson plans that span across 16 weeks of lectures and labs, where each week we have 2 hours of lectures and 2 hours of labs, we taught multiple automated tools during the lab sections, including unit testing with JUnit, eVersus for automated test generations, Peak, metrics plugin, and then we also taught them to use 3 static analysis tools, including PMD, Checkstyle, and FindBugs. And then we also encourage them to look at Java docs by introducing Doxygens, which helps them to generate HTML documentations automatically. Another key features of the GitHub-OSS Fixit is the use of resources from peer tutoring. That is, we ask previous students on how to start from zero, involving in open source projects and resolve their issues. We have conduct 2 kinds of peer tutoring, including conducting an interview via instant messaging and video by senior students. In the videos that have been recorded by our senior students who have taken software engineering class and software testing class, he actually shows videos that shows all the steps from finding a bug in open source Android apps, preparing a test cases that shows the importance of using test-driven developments, filing and GitHub issues, fixing the bugs by creating the pull request, and then having his pull request being accepted by the developers. Students actually find that these videos to be quite useful in helping them to get started with the GitHub-OSS Fixit projects. In another peer tutorings, we actually conduct an interviews by asking the students' helpers about what is his opinions about how to start from zero involving in open source projects. According to him, he thinks that Git and GitHub workflow is one of the most important parts in contributing to open source. And in fact, students in this class have been using Git and GitHub Classrooms for all the homework submissions. And what is another important aspect of this is that he asks us to encourage students to use the selected open source projects or libraries so that when they get familiar with it, they know how to find the bugs and how to work with the open source issues. According to the survey results that we have conducted, in the experimental setup, we asked 154 students in a class where only 140 students participate in these surveys. Our survey focused on answering the questions what are the benefits and the disadvantage of GitHub-OSS Fixit, and whether they think that GitHub-OSS Fixit is a good project. And then we are interested in knowing how many issues the students can resolve during the GitHub-OSS Fixit projects. In these results, we realized that students noted that one of the key benefits of GitHub-OSS Fixit, it allows them to learn about XP practice, including coding standards and also static analysis. Of course, because they need to actually fix bugs in the teams, it also helps to improve their teamwork skills. Another key benefit is that it helps them to read and understand other codes. And there are also things that is a practical projects because they can contribute to open source. In another measurements, we realized that even though we have only 154 students, these students are able to make over 200 pull requests to open source softwares. And then 93 of these pull requests are actually being merged. So a majority of the pull requests being issues are actually being merged or being closed by the open source projects. And overall, they actually think that they will recommend GitHub-OSS Fixit for future software engineering course. This is the end of my presentations. I'm happy to take any questions, but for those of you who are interested in our GitHub-OSS Fixit projects, please look up at our websites. Thank you for listening.
Hello, everybody. I am Ana Moreno. I am one of the co-chairs of the education track at ICSI. This is our first session, so welcome everybody. As you know, we have a quite different ICSI conference, so I'm not going to introduce the track, either the papers, because we go directly to the questions, to the QA sessions of the different papers. So we have one of the authors of this paper. She's Shin, and we already have one question in the chat. So if you like, you can write your questions in the chat, or you can raise also your hands. So the first question is for Chung. The question is that related to some students can be very enthusiastic, some find very complicated bugs, which might not be realistic. And the other spectrum, some other students might just identify some very simple to fix bugs. So the question is, do the students need to get approval from lecturers or tutors to approve the chosen bugs?
Yes, I think this is a very interesting question because we actually essentially want to have a trade-off between the freedoms that we give to students in choosing the issues, and then also basically the difficulty of the issues. So we basically allow students to choose the issues based on kind of how they judge their expertise is. And then the requirements is that we want them to have not trivial fix. So if it's just like a null pointer check that require just one line of code, we don't allow them to fix it. But otherwise, like we just kind of allow them to choose any kind of things that they are interested. And then if they are not clear whether they can choose these issues, they can get some confirmation from the lecturers. So basically from, yeah.
Okay, thank you. There is another question from Ari. He says, did you contact the open source maintainers of the system that the students contributed to fix? If so, how did you react?
We actually didn't contact the open source maintainers upfront. So we just kind of basically want students to get the feeling. So we did get some kind of problems with like some students actually like get no response from the open source maintainers. But then like this semester actually we have the second iteration, like so it's second time we are conducting this GitHub-OSS Fixit, and then we improve by letting them making sure everyone's comments in the issues that they want to fix to kind of have these collaborations with the or upfront communications with the developers saying that they are interested in the particular issues. And then this is actually better because like that they know that whether some open source maintainers will actually respond to an issues or some will not respond. So we encourage them to get upfront kind of confirmations from the developers, basically.
Mm-hmm. Thanks. I have another question that is related to how do students estimate which is the effort that it takes to fix an issue. For example, you mentioned in the paper that you don't allow to solve issues that would take less than 10 lines of code, or that issues should take 1 or 2 weeks to be fixed. So how do students estimate how much effort they assume that fixing an issue will take?
That's very interesting questions as well. Actually, this is one of the main difficulties that students say. It's about that find it difficult to estimate the difficulty of the issues. So we just kind of the difficulty is actually relative because they need to choose a number of issues. So they can choose it actually based on which issues are more difficult. Another one is more easy, and then we recommend them to start with easy issues first. And then another thing that we trying to compensate for this is that we allow them to change the issues that they are fixing, because we know how things changes, because the issue can be closed in the middle, and then it could also happens that someone else fix it, and then or this no longer reproducible. So we do actually allow them to change the issues they have fixed, that they have chosen initially. So we think that this is important measurements, because this is like the iteration planning in XP that I think like students will need to learn about, like how to estimate the efforts required for doing certain things, I think.
And do they take real data about the effort that it takes, the real effort that they spend fixing the different issues? So this data can be helpful for next iterations?
That's interesting questions. We didn't measure this because I think like it's too difficult to measure also whether how closely is related to it. At the end, actually, to be fair to everyone, we kind of say that everyone need to fix like one or two issues, two issue maximums, I mean minimum for the entire semester. So it's kind of like estimations to prevent people to fix too little versus like not contributing enough kind of things.
Okay. We have another comment from Ari. He says, in my course, I also let students contribute to open source. I encourage them to start with the simplest issue possible, similar that you mentioned, such as fixing a grammar mistake in the documentation. Is that option for your students too? It helps them to, it helps them in particular to go through, for example, CLA for the first time.
Oh, that's interesting. We do notice that there are some simple issues like involving documentations, but because we are still teaching a software engineering class, essentially we still want them to write tests, to run static analyzer. So we want them to use a lot of automated tools to help them in fixing the bugs. So we don't actually we actually disallowed them from fixing or choosing issues that are kind of documentation oriented, because that will means that they will not write any real code. Then there is no test, and then they couldn't run static analysis, for example, on it.
Okay. And we have another question from Alexander. He thanks for the talks, and he says that not all pull questions have been merged and closed by open source developers. Have you received feedback from the developers on why they were not merged?
Yes, actually, we received some feedback. We find out that from last semesters, a lot of students actually just mentioned that, okay, I'm busy with my exam, and then don't have time to like change the pull request according to the developer feedback. Some people just kind of abandon the projects or abandon the GitHub issues after just initial pull requests. So this semester, when we kind of know about this, and then we just have summarized a list of things not to do for when you make a pull request, and then we hope that in this semesters people will actually have better pull requests, and then like not making all the different mistakes that is common in making a bad pull request, basically.
Okay, thank you. We have one last question from Tim. He says that in some open source projects, there are issues that have been added by external users that project leads would never consider merging. Not real bug, for example, or the component will be replaced to fix not needed. This could disadvantage some students if they work on this. This explains why pre-arranging with open source developers is needed. What do you think about this?
Yeah, I think this is actually a big problem that we have for C. That's why we actually recommend in the instructions that we say that they should choose maybe issues that have special tag, like health wanted, or things like good first issues, and we have this recommendation as guideline for them to say that this issue is likely to be more important. Otherwise, we just kind of